The following presentation is brought to you by Discovery Channel School, a leading provider of quality educational resources that help teachers bring the world to their students.
Consider this before viewing Discover Magazine, Chemical Detectives. What do you know about forensic science? How does it help solve crimes? As you watch the program, note the methodical way in which scientists solve a mystery. Consider why it is important to be so meticulous. Assignment Discovery now presents Discover Magazine, Chemical Detectives.
In 1944, as World War II was raging, Americans in the Northwest began seeing and hearing things they couldn't explain. Authorities were soon piecing together an incredible story. Balloons of unknown origin were descending across the West. Robert Mickish is an historian. He investigated the balloon story for over 30 years.
In Wyoming and Montana, they began discovering quantities. Not really sure what's happening or what these balloons are for, or particularly where they're coming from. It was a mystery.
Since sightings were concentrated in the Northwest, authorities believed that someone was launching the balloons from a West Coast beach. But why? The answer to that question quickly became clear. The balloons were carrying bombs. The United States was under attack. So far, no one had been hurt. The balloons were coming down in remote areas. Many of the bombs failed to detonate. The military captured a number of balloons intact. Investigators examined these balloons for clues to their origin. They discovered strange mechanical devices, probably some sort of guidance system. They also found bags filled with sand, no doubt used as ballast. And they made one more startling discovery. Tucked inside one of the balloons was a piece of paper. It was an inspection tag, written in Japanese. Were the balloons coming from Japan? Impossible. A balloon could never survive the flight from Japan over 5,000 miles across the Pacific, all the way to North America. Or could it? Fire! We were, of course, at war with Japan. The U.S. government had forcibly moved thousands of Japanese Americans into internment camps. The military now suspected that Japanese agents were operating a balloon launch site from inside one of the camps. And while they searched to find it, the onslaught continued.
The military was wondering what is to come. Is this just a prelude? Are we seeing the maximum effort? And therefore, they wanted to keep as much speculation out of the public mind as possible.
The government also wanted to keep news of the balloons from reaching the enemy. So a decision was made to suppress the story. The Office of Censorship issued a secret request to newspapers and radio stations to keep all reports about balloon sightings out of the news. By now, the Army had begun studying the balloons. As engineers began dissecting the control units, samples of the sand were sent to the United States Geological Survey. The military wanted the geologists to tell them where the sand came from. If the balloons were being launched from a hidden U.S. beach, maybe the sand could lead them to it. The assignment was mind-boggling. This sand could have come from any beach in the world. Was it even possible to determine which one? Mark Van Balen is a geologist at Harvard University. He studied the work of the balloon bomb scientists.
The survey geologists were faced with a rather difficult and unusual assignment. The interesting thing about sand is that there are many different types of grains, and each grain has its own message.
No two sands contain exactly the same mix of minerals. To find where the balloon sand was coming from, the geologists had to determine what it was made of. They first sorted the grains into piles of similar color and texture. Some grains were translucent. These could be studied under the polarizing microscope. The range of colors gives clues as to their mineral content. The team also found microscopic animal and plant fossils in the sand. Their shapes are clues to their place of origin. While the geologists studied the sand, engineers studied the balloons. Incredibly, they were made entirely of rice paper, glued together with vegetable paste.
It was so bizarre from other weapon systems that were being devised. We're talking about B-29 super fortresses. We're talking about airplanes reaching supersonic speeds or touching upon it. And yet here is a weapon system that is designed primarily and solely to be carried to the enemy in a paper bag.
But the paper bags were guided by an ingenious delivery system, and the engineers had now figured it out. Upon release, the balloons floated upward. As the sun heated the balloon, it would expand and rise. But if it expanded too much, it could burst. So a valve would open, releasing excess pressure. As night fell and the balloon cooled, it would descend. But if it dropped too much, it could crash. To prevent this, an altimeter would close a switch, igniting a charge. The blast released a pair of sandbags, lightening the load. When all the sandbags had been released, a final charge would release the bomb. Now that they understood how the balloons flew, the engineers were asking another question. Why did the balloons carry so many sandbags, enough to travel for several days and nights, if they were coming from the U.S.? Because they weren't coming from the U.S. The balloons were coming from Japan. The Japanese had discovered a weather phenomenon unknown to the Americans. Over the Pacific, high in the atmosphere, were fast-moving winds that could quickly carry a balloon across. We now know these winds as the jet stream.
They discovered what would normally take 6 to 8 days of travel of a balloon, which would be pretty testy. They could do this in about 33 hours.
By now, the geologists had completed their study of the balloon's sand. They next had to compare the sand with the known geology of Japan. If the sand could be traced to a specific region, that might help them pinpoint the balloon launch sites. Before the war, Japanese geologists had spent decades mapping their country's rock deposits. Those maps would soon prove invaluable. As it turned out, the sand was unusual, not only for what it contained, but for what it did not. For instance, it contained no granite, one of the most common rock types on Earth. It also had no coral fragments. But it did have high concentrations of some rare volcanic minerals. These were important clues. The lack of coral meant that all beaches below the 35th parallel could be ruled out. Coral is almost always found in the warm waters that wash these beaches. The absence of granite in the sand eliminated other beaches. The peninsula east of Tokyo seemed to contain the right mix of volcanic minerals. The beaches here were strong suspects. The final clue came from the microscopic plants and animals. It turned out that the ones found in the balloon sand had been found before by a French geological expedition to Japan in the year 1889. The location of the find was a beach named Ichinomiya. The evidence seemed clear. The geologist concluded that the balloons were either coming from Ichinomiya or beaches just up the coast at Sendai. Photo reconnaissance planes were sent out to search for launch sites. They returned with pictures of what appeared to be partially inflated balloons and hydrogen generators. The geologists had been right. From a few grains of sand, they had found the launch sites. American B-29s bombed the area, destroying 2 hydrogen plants supplying the balloons. As suddenly as they had appeared, the balloons stopped coming. There would be no more balloons. The bombing raids had done their job, as had the news blackout. With no evidence of success and their factories damaged, the Japanese had already abandoned the balloon bomb offensive. From November of 1944 through April of 1945, Japan launched more than 9,000 paper balloon bombs against the United States. U.S. government records can only account for about 300. It's possible that some of them may still be out there. In a small Florida town, an abandoned, boarded-up house sits like an old ruin. Buildings burn for all sorts of reasons. Space heaters catch fire, people smoke in bed. Even a forgotten pot roast can start a deadly blaze. But one of the leading causes of fire in America is arson. Arson is committed for revenge, terror, and profit. It destroys communities and leaves blackened scars across the face of America. But now, fire investigators have a new tool in the battle against arson. Bill Whitstein is a certified arson investigator.
You got a fire?
When there's a suspicious fire in this part of Florida, Bill gets called.
All right, tell him I'll be there in about 20 minutes.
But Bill doesn't work alone. He always travels with his partner, an arson detection dog named Villain.
You go to work? All right. Good girl. Come on. Go. Come on. Come on. Go to the fire.
Even when investigators suspect arson, proving it can be tricky. They need to find evidence the fire was intentionally set. That's where Villain comes in.
See? See?
She's trained to sniff out and pinpoint the tiniest traces of chemicals, like gasoline, that arsonists usually use to start fires.
Show me. Show me. Good girl. Good girl. You got a spot right here already, Ron. See? See?
Bill carefully guides Villain around the room.
See?
Every place she detects
Show me.
accelerant, she alerts
Good
Bill.
girl. Good girl.
He instantly rewards her with praise and food.
Some good strong alerts here, Ron. There's another one right there in the carpet.
Next, investigators take samples from wherever Villain has indicated the presence of accelerant. Since gasoline evaporates quickly, these samples are sent immediately to the lab.
The old way of investigating a small room, you might have to take 10 or 15 samples and send them to the lab and hope you got a sample. A dog can go into a scene and within a minute or two accurately pinpoint down to the size of a quarter flammable liquid or gasoline. Show me. Show me.
After thoroughly checking inside the house, Bill and Villain move outside.
Good girl.
Fire investigators know that many arsonists like to watch their work. The perpetrator might still be at the scene. So Bill has Villain work the crowd. Villain detects accelerant on this man.
Show me. Good girl. Good girl. How you doing?
Sir, I'm Inspector Timmer, Fire Department. Would you step over here with me for a minute,
Is there
sir?
a problem?
Good deal.
Meanwhile, at the lab, forensic chemists check the samples from the fire. Tiny fragments of the sample are placed inside a gas chromatograph mass spectrometer, which yields a complete chemical analysis of the sample. The readout shows benzene, norpar, and other hydrocarbons, ingredients of gasoline. With the lab and the dog in agreement, the sample becomes strong evidence that can be used against the suspect.
Well, Steve, we busted you again, man.
But today's suspect isn't a real arsonist. He's a Dade County fire investigator.
See? Good girl. See?
The entire day has been a training exercise to help keep Villain on her toes. How do dogs do it? How do they accomplish these olfactory feats? First of all, dogs' sense of smell is at least 100,000 times greater than humans. This may be partially due to the large number of odor-sensing cells inside their noses. And dogs' brains may also be wired more effectively for smelling than humans. Scientists believe that for dogs, the sense of smell seems to be crucial to survival. Almost from the moment they're born, these puppies use their noses to locate mother's nipple and explore their world.
Puppies, 15 minutes of age, have this, what apparently is a reflex to a novel odor, and that is that they sniff.
Dogs also have an uncanny ability to discriminate between different odors. But scientists know next to nothing about scent discrimination, the very talent that makes arson dogs so effective. Today, arson dogs from all over the country are gathering at this hotel in Georgia. They're here to help Dr. Larry Myers and Kevin Lothridge perform a series of scientific tests on their ability to discriminate between different odors. For these dogs, a hotel stay is nothing new. Since they get worked every day, the dogs always travel with their handlers, even on family vacations.
Now, when I travel the state, we stay in a motel, and usually I'll get double beds so you can have one and I can have one. I know it. I know. Yeah.
Today, the dogs will be tested in an attempt to answer a deceptively simple question. Just what is it in gasoline that the dogs are smelling? To find out, Lothridge starts with a basic scent discrimination test. Materials like wood, carpet, plastics, and styrofoam are found in almost every modern building. In a fire, these materials give off choking, putrid odors. An arson dog has to be able to pick out the scent of gasoline from a background of strong burnt odors like these. Lothridge will place a tiny amount of gas, less than a baby's teardrop, into one of the cans.
Ready? Look. See. 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 See.
Villain finds the gas easily.
Show me. Good girl. Good
It's
girl.
clear she can easily discriminate between gasoline and strong
Good girl.
background odors.
Good girl.
But how does she do it? What is it in gasoline that she recognizes? Gasoline is made up of hundreds of chemicals. Dogs are probably more sensitive to some than others. But which ones? For this test, one can is spiked with solvent 100, an ingredient of gasoline. At the other end of the hall, the spiked can will hold a chemical called Norpar, also found in everyday gasoline. Will the dogs recognize these gas ingredients as easily as they recognize gasoline itself? Neither the dogs nor the handlers know what the cans contain. The first dog alerts to the solvent 100 just as if it were gasoline. Then he inspects the second set of cans. He finds nothing. The Norpar doesn't elicit a response. Dog after dog shows the same thing.
That one was actually B.
Solvent 100 yes, Norpar no.
That one is Norpar.
What does it all mean? Myers and Lothridge suspect that there are only a few compounds in gasoline that these dogs recognize. Eventually, the scientists hope to identify those compounds.
See. See. See.
Then they'll be able to look for the dog's specific olfactory receptors to those chemicals. This may someday yield a greater understanding of human olfaction as well as dog olfaction. That will help the dog handlers improve their training methods. Dogs are playing a bigger role in law enforcement and public safety. Drug-sniffing dogs are now common sights at airports and post offices. They patrol the nation's borders, where they uncover hundreds of tons of illegal drugs every year. Like these other specialized dogs, arson dogs play an increasingly valuable role in fighting crime. The scientific work to understand and improve what they do will ultimately save lives by putting the arsonists out of business forever.
Keep watching. Discussion topics and activity and resources for Discover Magazine Chemical Detectives are up next on Assignment Discovery. Now that you've seen Discover Magazine, Chemical Detectives, talk about this. The balloon bombs left many clues for scientists to investigate. Describe the method used to solve the balloon bomb mystery. Is this an example of the scientific method? Give examples from the video to support your case. Now try this. Take a small sample of soil from your home and one from your school. Examine each sample under a magnifying glass or microscope. How do they compare? Log on to discoveryschool.com for curriculum materials and resources to support Discover Magazine, Chemical Detectives. To learn more, Assignment Discovery suggests Crime and Detection by Brian Lane.